I was thinking to myself, what could we do as a challenge to help verify that we understand the concepts of IP addressing for IPv4 as well as subnetting? So I thought to myself, well, if somebody's gone through most of the nuggets in this module, and they've been following along and doing the assignments and practicing along with me as I've invited you to, I bet you they could pull off this scenario right here. So here's the topology we're going to go ahead and use. We have two routers, R1 on the left, R2 on the right. There are a total of 3 networks. There's a network here, there's a network here, and there's an IP network here. And what I would like you to do is take the scenario where we have a network of 10.20.0.0 with a 16-bit mask, and we're going to do custom subnetting, and we're going to extend the mask out to 21 bits in length. So in one of our nuggets, we identified on how to do that and also how to identify the new subnets that would be created. And then as far as applying those subnets, I'd like to go ahead and apply the first subnet here, the second subnet here, and the third subnet right here. Also, for the routers, for their IP addresses on the new subnets, I'd like to use .1 in the last octet for R1 and .2 in the last octet on the interfaces for router 2. And the PCs are already configured and ready to go. They're just waiting for the rest of the network. So what I'd like you to do is take some time and calculate what those new subnets would be and also what the IP addresses would look like on the router interfaces. I'd invite you, when you're sitting at a computer and you're logged on to CBT Nuggets and you've got the link for the virtual lab, to go ahead and launch the lab and actually practice putting in the IP addresses you believe to be correct for each of these subnets. And one of the things that we'll want to know as we apply IP addresses is what vendor or what type of router are we using, because the commands are going to vary slightly based on the type of vendor that we're using. So because router 1 and router 2 are both from Cisco systems and they're Cisco routers, let me give you a brief walkthrough of how we'd apply an IP address to a Cisco router. We type in config-t, that's short for configure space terminal. That would put us into what's called global configuration mode. And then once we type in interface space gig space 1/0 and press enter, that puts us into a logical place called interface configuration mode for that specific interface. And it's at that point we can go ahead and configure an IP address on that interface. So we would put the IP address here. These 4 octets are the IP address. So R1 is always going to end in .1 in this topology, and R2 is always going to end in .2. And this octet right here is going to have our custom subnet value. And then the following number here is the network mask. So we know what the mask is going to be. It's a /21, but on a Cisco router, we're going to enter that as dotted decimal. So whatever the dotted decimal equivalent is, a /21, that would go right here. And once we press enter and have configured the IP address, we can type in exit to exit out of interface configuration mode. And then on this router, we can go to interface gig 20. And then we can do the similar treatment for router 2 with its gig 1/0 on the right and its gig 2/0 here on the left. So what I invite you to do are 3 basic things. Number 1, before we do the walkthrough together, consider taking some time and actually calculating the subnets and the IP addresses involved on your own, and then you can compare them to what we do together as we proceed through the nugget. Secondly, if you're at a computer logged on to CBT Nuggets and you want to practice putting in the interface IP addresses on the router, you certainly can. Because if you're logged in from a computer, there's a little link for the virtual lab that you can click on that will launch the lab and give you the opportunity to go to the interfaces and put in the IP addresses and verify it that way. And the third thing, besides having fun, is that if you ever run into some aspect where you're not quite sure of it, please go back and revisit the nuggets in this module to reinforce the concepts so that you feel confident about understanding the basics of IP addressing and subnetting, and with this lab, a little bit of hands-on implementing IP addresses. And for those of you who plan to work this through and then test it before going through the rest of the walkthrough, one simple way to verify that everything is working is that when you're done with the configuration on router 2, you could exit configuration mode and do a ping out to PC1's address at 10.20.0.11. And if that works, that's a way to verify that your configuration is correct. To solve this, one of the first things we could look at is the new mask. It's a /21, which means that we have a block size of 8. So if the original network is 10.20 with the 16-bit mask, the first 2 octets are going to stay the same. And the first subnet, subnet 0, is going to have a 0 there. The next subnet will be incremented by the block size in that same octet, which would be 8. And the third subnet is going to be 16. Once again, incrementing it by the block size. And then we're going to have a trailing 0 to make the 4 octets of a network address. And those are all going to be /21. So subnet 0 is going to be the first subnet. Subnet 8 is going to be our second subnet. And subnet 16 is going to be our third subnet. So the IP address on router 1 on this 10.20.0 network is going to be 10.20.0.1 with a 21-bit mask. However, when we implement that mask, because we can't use a /21 here, we have to do dotted decimal. It's going to be 255.255. And then 248, which represents 5 bits from that third octet being used for network addressing, followed by a 0, and that's the dotted decimal equivalent for a mask of /21. So on R1, the interface IP address would be 10.20.0.1 with that mask. On the gig 2/0 interface, it would be 10.20.8.1 with a 21-bit mask. On R2, the interface here, gig 2/0, would be 10.20.8.2 with the same mask. And then gig 1/0, connected to subnet 3, would be 10.20.16.2 with a 21-bit mask. And if those IP addresses are all implemented correctly, these PCs, PC1 and PC2, have already been configured to use R1 and R2 respectively on their local networks as their default gateway. Also, there's a dynamic routing protocol already running on R1 and R2. So if the IP addresses are put in correctly, there should be full reachability between all these subnets, and PC2 should be able to ping PC1 and vice versa. So I'm using our lab gear at the moment, so if you launch the lab from a computer, it'll look exactly the same as this. So at the moment, we're on router 1. Also, if you need a peek at the topology again, if we minimize this terminal window, it's right there if you ever need to look at it. So let's go ahead and bring back the terminal window. And here on router 1, we'll type in config space T to go into configuration mode. Then we'll type in interface gig 1/0 and press enter. So typing int is a shortcut for typing the whole word of interface. And then here in interface configuration mode on R1, we'll give it the IP address of 10.20.0.1. Had to think about that for a second. And then we're going to put the 21-bit mask in dotted decimal, which is, there's 8 bits of it, there's 8 more, and there is the last 5 for that third octet, .0, and that is the IP address. And what it loved about that was the fact that, Keith, you got to follow the syntax. And so if you have a problem or you didn't do the syntax correctly, it's going to bark at you. So what I failed to do is type in the word IP address. I got so excited about the IP address, I failed to type in the word IP address. So I'm going to fix that IP address space and press enter. And I wanted to show you that at least once so you don't feel bad. Because if it's the first time you've configured a Cisco router, there's going to be some things where it barks at you, and it's cool. It doesn't have an attitude, and it'll let you try again and again. So no worries. Next, let's go ahead and exit out of interface configuration mode. We're still in global config. Let's go over now to interface gig 2/0. We'll do that by typing in interface gig 2/0, and then from here we'll do IP address for this new interface of 10.20, and this subnet is subnet 8. And then we'll put in the last octet of .1 with the same mask. And press enter, and it's done. So we'll type end. You can also type exit a couple times, that'll get you out. But either way, we're out of configuration mode, and we've assigned those IP addresses. Let's go ahead and configure router 2. So we'll hit the tab for router 2. So here on router 2, what we'll do is we'll go into interface gig 2/0. That's the interface that faces R1. It's between R1 and R2. And we'll give it the IP address of 10.20.8.2. That's the 8 subnet with the 21-bit mask of 255.255.248.0. And you'll notice once we've done that, because there's a dynamic routing protocol running, specifically EIGRP from Cisco systems, the moment that R2 has an IP address, they're communicating back and forth, R1 and R2, willing to share with each other routing information. And that's really important because we're going to need full reachability and routing information if we want a packet to be able to cross all 3 subnets. So let's follow up with the interface on the right of R2. That's interface gig 1/0. We'll give it the IP address of 10.20.16. This is the 16 subnet, .2, and the 21-bit mask of 255.255.248.0. And then we'll type in end to get completely out of configuration mode. So next, let's test this by going over to PC1 on the far left, and let's do some connectivity testing. And on this virtual PC, in this lab environment, if we do a show IP and press enter, it's going to show us its current IP information. So it's got the IP address of 10.20.0.11 with a 21-bit mask. That third octet represents that this indeed is subnet 0. And it's also got a default gateway configured of 10.20.0.1, which is the IP address we configured a few moments ago on R1's gig 1/0 interface. So let's go ahead and do a ping of 10.20.16.22, which is PC2's address on the right-hand side of our network, and we'll press enter. And that looks great. That's a home run from end to end. And if there's any portion regarding the IP addressing or the subnetting that was foreign to you, or you want to revisit again, I would invite you to take a look at the previous nuggets on IPv4 and subnetting in this module, which cover each and every one of those details that led us to this point of implementing IP addressing on a routed network. I'm glad that you joined me for this nugget and lab. I hope this has been informative for you, and I'd like to thank you for viewing.